So, in the previous lecture, we find the Christoffel symbols for first kind. Now, in this lecture, our aim is to find the symbol for second kind. How we can find the Christoffel symbol of second kind. Now, so that is a part B. So this is a Christoffel symbol of second kind. Now, go to the second part. What is the formula for Christoffel symbol of second kind? That is Kij, which is equal to GKL Ij, comma L. Right? So this L is a new number that we introduced. Now this is a sum of the number of coordinate axes. Now in this case, the number of coordinate axes are 3. So L is running from 1 to 3. Similarly, I is running from 1 to 3. Similarly, J is running from 1 to 3. But in particular case, when IJK is constant, that is fixed, in that case, L is running from 1 to 3. So this will become GK1, IJ1, GK2, IJ2, GK3, IJ3. This is equation number 6. Now from this equation, we can find the Christoffel symbol of second kind. Now, the simple way, now our first part is 1, 2, 2. So just substitute I and j equal to 2 and k is equal to 1. So it will become the equation in this form. Clear? So in this equation, our need is this values, this values, and this values that we already find it. Similarly, this values, and this values. Clear? So if we already find these all of these values, if we need to find it, then find it again. Now we know that what is G11? Its value is 0. G12, its value is 0. So G13, its value is 1. Clear? So in this case, if Ij, the value of G11 is not 0 because it is a this value. This value will be 1. So correct this form because when I and j are not equal, in that case the value is 0. So G12 is 0, G13 is 0. This is 0, but G11 is 1. So correct this term, that is not right. So G11, this is equal to 1, G12 0, and G13 again 0. So in that case, it will be G11221 because this term will be 0 and this term will be 0, right? If this term 0, this term 0, so in that case, this value is 0, this value is 0. So we get G1122, 1. Now what is the value of G11? Right? So that we find it from G11. So in the previous question, that is G11, that is equal to 1. Right? Second is the value of G11 and second value is 22, 1. Right? So its value 22, 1, that is crystal symbol of first kind, 22, 1, its value is equal to minus r. Right? That is in equation number 4. So substitute these values in this equation, 1 into minus r. So this value will become a minus r. Right? This is our result. Similarly, in case of 3, 1, 3, now I is 1, j is equal to 3, and k is equal to 3. So again, we substitute the value in this equation, right? Here I equal to 1, j, and the value of j and value of k in this equation. So it is a sum of 3 terms, right? Now, if it is a sum of 3 terms, we know that this G32 and G3 1. These are not diagonal entries. These terms are 0. That is given. If these terms are 0, the first part of equation is 0. Second part of equation is 0. Right? So remaining part is this. Now what is G33? G33 is equal to 1 by r square sine square theta. And what is 1 3 comma 3? So this is r sine square theta. Then what is its value? That is equal to 1 by r. So similarly, we can find the any Christoffel symbol of a second kind that we need to just understand the concept how we can substitute the value of I, J, K and L. Now, in our next part, this is very important result. Evaluate Christoffel symbols of first and second kind in rectangular, cylindrical, and spherical coordinates. Right? So it is exercise for you. So calculate. So this is again mistake. So that is evaluate. Okay. So to find the Christoffel symbol of first and second kind. So that is for rectangular, cylindrical, and spherical coordinate. So these are very important questions, may be expected in any university examination. So practice it on the similar pattern that we already done. Similarly, we can take some another example, calculate the non-vanishing Christoffel symbol of corresponding metric if we have any kind of metric. So there is some special case in case of metric here given is a function of x, y, z, right? And it involves the four variable x, y, z and t. So remember this thing, it does not contains three variable, it contains four variable and also one function. Clear? So this question is much important and better than the previous result. Now in this case, take x1 equal to x, x2 y, x3 z, and fourth coordinate x4 that is equal to t. Right? Now this metric is converted in this form, this values. Now this function f, which is a function of x1, x2, and x3, because it was a function of x, y, z, right? So now from this we get g11 diagonal entry minus 1, g11, g22, g33, and g44. Remember, and other entries are 0, right? So g11, g22, g33, and g44. So other entries are 0. It means these coordinates are orthogonal. Clear? So that is the basic previous concept. If the diagonal entry are non-zero, other are 0, then the coordinates are orthogonal. In that case, we can find reciprocal coordinate directly, because reciprocal coordinate of this is again minus 1, this is again minus 1, this is again minus 1, and it is 1 by f, because in that case that is a reciprocal, and in the other case the value is 0. So by using this concept we get directly, or we can also find it some another way, that is by taking cofactor, but here we find directly by taking the reciprocal. Now again, what is the formula for ijk? So again, I connected with k, j connected with k, that is positive, and last term combined ij connected with k, that is negative. So remember this formula. So first write the formula, then substitute the value of ij and k. Now in this case, what is I? 1. What is j? 4. What is k? 4. So substitute, right? Now what is x4? x4 is t. x1 is r. x1 is x, and x4 is t. So just substitute the values, right? Then this value will 0, this value is f, g44 is f. Only diagonal entries are non-zero, other are zero. So this will zero, this will zero. So only we get this result, 1 by 2 curly f by curly x, right? So similarly, 4, 1, comma 4, this is 1, 4, comma 4, because it is symmetric in nature, that we prove in later. So symmetry in nature, then both are equal. So they have the same values, 1 by 2, curly f by curly x. Again 2, 4, comma 4, which is 4, 2, comma 4. Again using the result, and we find the value 1 by 2 curly f by curly y. Similarly, in case of 3, 4, comma 4, so just use the given formula, then substitute, then we get final values. Again by symmetry, 3, 4, comma 4 and 4, 3, comma 4 are equal. Again in case of 4, 4, comma 1, right? So first 4 is connected to 1, 4 is connected to 1. So 4 is, these are positive, and then combined is connected to 1. So these are negative, right? So similarly 4, 4, 1, 4, 4, 2, 4, 4, 3, right? So here we can find the values of these. These are all non-zero values. We can also find the other values in similar pattern, right? So if we need to find that values, then then we will find it. Otherwise, now next is second kind, symbol for second kind. Again the formula. So G4L, this is 1 4, and L is, now L is running from 1 to 4. Remember, clear? Now L is running from 1 to 4 because we have 4 variables. So this will become, this value is 1, 2, 3, 4. And we know that the diagonal entries are non-zero, other are 0. So this will become 0. This will become 0. This will become 0. The remaining part is only this, G4, 4. And 1, 4, comma 4. We know the value of G4, 4. We know the value 1, 4, 4. Substitute and get the result, right? On similar line of action, we can find 4, 2, 4. Similar line of action, we can find 4, 3, 4, right? Similar line of action, we can find 1, 4, 4, 2, 4, 4, right? Similar line of action, we can find the 3, 4, 4. Similar line of action, we can find the all Christoffel symbol of second kind. Clear? So that is the method. By using this method, we can find the Christoffel symbol of first kind as well as second kind. So practice it. So practice it, all of these questions. Now, next is the property of these symbols, which is of first kind, this is of second kind, that we will discuss in the next lecture at that time. So practice to find out the Christoffel symbol of first kind as well as second kind.